Hey everyone, welcome back to Robo Request. You ask, we bet. Each month, we bring you creative ideas to life with an exciting robotics project. And this time, we got something really powerful and interesting. A pan-tilt surveillance car using ESP32-CAM with live control. Now, this project is inspired by your awesome request from Durgajaya6379 who asked for a complete tutorial on this surveillance project. Big thanks for your amazing idea. Keep your request coming. Your idea could be our next project. So before starting the electronics part, make sure your robot chassis is assembled properly. If you have not assembled it yet, check out our chassis assembly video from the link given in the description and the I button above. Also, the 3D design file for the pan tilt camera structure are available in the description below, so you can easily print and assemble your own setup. Now let's dive into the project. Here's what we will need for this project. An ESP32-CAM module, an ESP32-CAM MB programmer for uploading code, one L298N motor driver module, one robot chassis with wheels, two servo motors for pan and tilt movement,
one buck converter UBEC for stable 5V supply,
a battery pack that is 3.7 volt rechargeable batteries. We need 3 batteries for powering the robot, some jumper wires, and a mobile phone or laptop to control the robot wirelessly. Well, let's start by setting up the connection step by step. Now first take your ESP32-CAM module and motor driver. Motor driver connections. Connect right motor ENA pin to GPIO 2, right motor in 1 to GPIO 12, right motor in 2 to GPIO 13. Left motor ENB pin to GPIO 2, left motor in 3 to GPIO 1, left motor in 4 to GPIO 3. Now connect. Motor driver VCC to battery positive, motor driver GND to battery negative. And make sure the USB32 CAM GND is connected with motor driver GND.
power correction, important update. Now we add a buck converter for safe power distribution. Connect battery positive buck converter IN plus, battery negative buck converter IN minus. Adjust the buck converter output to 5 volt using a multimeter. Then connect buck converter out plus 5V breadboard positive rail, buck converter OUT, breadboard negative rail. Now from the breadboard rails, connect breadboard positive rail ESP32 CAM 5 V pin, breadboard negative rail ESP32 CAM
GND. Now servo motor connection pan tilt system. Now take the pan servo motor, connect servo signal pin to GPIO 14, servo VCC to
breadboard positive rail,
servo GND to
breadboard negative rail.
Next take the tilt servo motor. Connect servo signal pin to GPIO 15, servo VCC to
breadboard positive rail,
servo GND,
breadboard negative rail. Also ensure all grounds are common. ESP32-CAM GND, motor driver GND, buck converter GND, breadboard GND rail, and servo GND must all be connected together.
These two servos allows horizontal and vertical camera movement. The ESP32 CAM already has a OV2640 camera module attached, so no external wiring is required for video streaming. Just ensure the camera ribbon cable is inserted properly. Make sure to double check all wiring connections with the circuit diagram before moving forward. Now let's move to the coding section. Download the code and required libraries from the link given in the description below. Then open the code in Arduino IDE. Now this project uses several important libraries. ESP_camera.h for camera control, Wi-Fi.h for wireless communication, async TCP.h for fast communication handling, ESP async webserver.h for web control interface, ESP32 servo.h for pan tilt servo movement. In this code, the ESP32 CAM creates its own Wi-Fi network. Wi-Fi name my Wi-Fi card, password 12345678. Now your phone connects directly to this network to control the robot. Next we define the motor control spin and direction. The robot supports forward movement, backward movement, left turn, right turn, stop conditions. These movements are controlled using web interface arrow buttons. A PWM speed controller slider is added inside the web page interface. Using this slider, you can increase motor speed or decrease motor speed smoothly. Pan tilt camera control. Two sliders control camera movement. Pan slider moves camera left and right. Tilt slider moves camera up and down. Now these sliders control the servo motors connected to GPIO 14 and 15. Light brightness control. Another slider controls LED brightness. This allows low light mode, medium light mode, full brightness surveillance mode. Allow video streaming system. Now the ESP32 CAM captures frames continuously and sends them using WebSocket communication. So you can see live camera footage directly in your browser without installing any mobile apps. Before uploading the code, connect ESP32 CAM with ESP32 CAM MB programmer. Then connect programmer to computer using USB cable, open Arduino IDE, select port, ESP32 rover module, then select correct COM port. Now click upload, wait until uploading completes successfully. Once uploading finishes, remove programmer and power the ESP32-CAM using battery supply. Now power on your robot. Open Wi-Fi settings in your mobile phone, connect to my Wi-Fi password 12345678. Now open your browser, type the IP address shown in the serial monitor or usually 192.160.4.1. Now the control dashboard opens. Here you can move robot forward, move it backward, turn left, turn right, control speed, adjust camera angle, control LED brightness, and watch the live surveillance video, all in one interface. Now when you press arrow buttons, robot starts moving instantly. When you adjust sliders, camera rotates smoothly and LED brightness changes accordingly. Meanwhile, live videos keep streaming continuously from ESP32-CAM, turning your robot into real wireless surveillance vehicle. And that's it. Your pan-chill surveillance car with live ESP32-CAM control is ready. This project is perfect for learning Wi-Fi robotics, ESP32-CAM streaming, web-based robot control, servo automation, and real-time surveillance system. If you enjoyed this tutorial, don't forget to like, share, and subscribe to Roboarmy and keep sending your project ideas. Because Robo request, you ask, we build.
Roboarmy. One-stop global community for teens in robotics and AI.